Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back to work over here on the project where I'm making a gear that will go onto a steam engine governor, if I remember correctly. Had a viewer sent this in. He had a broken gear on his engine. He sent the old gear along. We were able to basically figure out all the dimensions and everything on it. So previously what I did is I went in, I took the gear blank that he had, and I drew it up in CAD and 3D printed a pattern for the gear blank itself, and we sent that over to Windy Hill Foundry. They actually cast a new gear blank out of cast iron, which is what the original was made out of. And then we took that casting, machined the blank. That was done in a previous video. I've got that right here set up on an arbor, and now all we need to do is cut the teeth in here. Now for this particular gear, a little bit of information on it. It is a 6 diametral pitch, so fairly coarse tooth gear, and it has 22 teeth. I have a involute gear cutter here. This is a 6DP, 6 diametral pitch, and this is the number 5 cutter. These cutters come in a set of 8 for every pitch, and depending on the number of teeth you have in your gear, you will choose the cutter for that particular range of teeth. And in this case, we need the number 5 cutter. I had one over in my cabinet full of cutters, so anyway, this is a nice, looks like a fairly nice sharp cutter ready to go. So we are ready now to go ahead and get the milling machine set up to do this job. I basically tore down the previous job. We're just down to just an empty blank milling machine. I'm going to be bringing the dividing head over. We'll get the dividing head set up. That will be used to turn it the proper distance each time to cut those 22 teeth. I'll need to set up an arbor with my cutter to get it going, and once that's done, we'll get in here and start doing some gear cutting. So let's get the dividing head over here on the machine. First things first, I want to make sure I got a nice clean table. Don't have any chips or anything on here. I'm just taking a brush and brushing it clean, and then I'm going to get a rag and wipe it down real good just to make sure everything's nice and clean and ready to go. This is a Kearney & Trecker model 3H horizontal milling machine. It's a universal mill, which means that you can tilt the table to do some unusual jobs. But nice size mill. The 2H is the more common size, a little bit smaller than this one. This is basically a size above that. All right, let's get the dividing head over here and up on here. I'm going to move the table out so that I can kind of bring this in. That dividing head is really heavy, and I got a lift table that I can put it up onto and kind of slide it over here, but I want to get it over as far as I can to get the table up on there. So to do that, I'll just fire the machine up. There we go. And we will just move the table out. That's far enough right there. I've got my dividing head over here on this little hydraulic lift table. So I'm going to lift this up as high as I can and just slide it over. I've got several heavy items up on this lift cart. Just makes it a little bit easier for moving things around in the shop. And that's as high as that goes. I think I can lower the knee down a little bit here to get it at the right height. This is the foot stock. I'll go ahead and set it up on here. I can pick that up fairly easily. This is the dividing head, and it's heavy. I use a Kearney Trecker Model K dividing head. K&T made 2 different versions. Actually, they made an older version too, but their more common ones were the Model K and the Model H dividing heads. And they also made Model H and Model K milling machines. Even though this one is a Model H milling machine, This Model K dividing head fits up on it. It's designed to work with it. So, all right, let me get this out of the way and we'll get that positioned. All right, I'm going to get this over here and I want to kind of get it up on the edge here on the bottom, and I just want to just clean the bottom of this. Make sure there's not anything on it to get between it and the table so that it sits nice and flat. There are some keys in here that fit into the slots that kind of square everything up like it should. There we go. There are 6 places to clamp it down. I will typically put 2 clamps on the front on the outside here, and then I'll just put 1 clamp in the back, clamp it in 3 places, and that's sufficient. As far as squaring this thing up, the keys in there are very tight. There's, I mean, just barely any play in there at all, and for what I'm doing, it's not going to matter. I'm not going to spend any time trying to get it dialed in, square, or anything like that. It's plenty good enough. And we'll tighten all these down. Okay, that is in place. The foot stock, I'll get it set in a little bit on the length of where it needs to be. Let me go ahead and get the table kind of raised back up and get that moved back over toward the center a little bit, and we'll finish setting this up. So next thing I want to do is get my arbor in here. This particular cutter needs a arbor that's 1¼ inch diameter, which is this arbor right here. I'm just cleaning up my 50 taper. We'll insert that up into the machine. There's a drawbar that screws into the back of this that tightens it all up. Basically just pulls it up tight into that tapered socket and holds that arbor in place. Let me get this set up. All right. So now we start building out our arbor. I've got a bunch of bushings here. These are just spacers that will go up onto the arbor, and we're going to build these out to where I want my cutter to be. So this takes a 5/16 inch key, and I've got a piece of key stock here. I'm going to rotate my bushing around to where it lines up. Then I will take my cutter. I want my cutter turning counterclockwise, turning where it's cutting, feeding into in this direction. So we'll go ahead and get the cutter on. One more short bushing in there, and then this is the bushing that is basically the bearing that's going to ride in the overarm support, and we'll put our nut on the end. Now, one thing I'll note here is I don't tighten this up until I get the overarm support on, because you got all this leverage. You can easily bend your arbor if you do it out here. If I put the support on and then tighten it up, it's going to not bend anything. So we'll just go ahead and get the overarm support on, and that's the next step here. I'm going to extend my overarms out. All right, we've got the support here, which will fit up onto these. There we go. Go ahead and tighten that in place. a little spindle oil. This is just a lightweight oil on that bushing that it's going to be riding on inside here. It's just a plain bushing. And I'll pull it up onto the arbor. Now, another little trick on these things is it's easier to get the top two supports on and pull the bearing on rather than trying to get all three of them in one shot there. And let's see, that's out toward the end of the bushing there. And I'm going to tighten up my overarms on the top. All right, so now those won't move. They're locked in place. That end's locked in place, and we need to tighten up the nut, and don't forget to tighten the nut. That's a surefire way of ruining a gear. Ask me how I know. All right, our arbor is built. So now that I've got the cutter in place, I can kind of see roughly where the center of this is, and I can also tell I need to drop down a little bit. I'll just use the power feeds here to make easy work of that. All right, that'll get me close. And I need to go down a little bit on the up and down. And I'll need to adjust my speed and all that. Let me figure out what speed I need to be running on this cutter. So I need to figure out the speed that I need to be cutting my cutter. And to do that, I'm going to use this little chip volume speed and feed calculator. This is a old school slide rule type calculator that K&T actually came out with to help figure all this out. And guys, I'll tell you, you can go to websites and put the information in and calculate it. You can get an app on your phone and do it, but this is the way they would have done it back before they had all the modern technology, and I still like to use it. Now that cutter is about 3 1/4 inches in diameter. So the way you're going to do this is up on this top scale, you're going to put in your cutter diameter, and you just slide this back and forth, and I'm going to put it on 3 1/4 inches right there. And then you need to know what the surface speed that you want. And on the back, there is a chart. And I've got a high-speed steel cutter. And I'm cutting soft cast iron. And it tells me that my surface speed needs to be between 100 and 120 feet per minute. That is the speed of the outside diameter of that cutter moving. So 100 to 120. I come over here, I find surface speed. In minute, I go to 1 to 120, and it looks like my RPMs I'll read right here, somewhere, just say 115 to 175 RPMs. About 125 RPMs would be perfect. So let me see over here what I got. Actually, I see 124. So we're going to probably go with that on the RPMs, and that should be the right speed for this particular cutter. So let me get that set up over on the mill. So this mill has a high range and a low range. You move this lever here, flip it over, and you either got red or black. So we got black, which is the low range. And I see 124 down here, so I'm just gonna kind of move it around. And, you kind of have to get your gears to mesh. But I got 124 now lined up on that one, so that should be the speed of the mill, and when we turn it on, that's turning 124 RPMs. Over on the front, there's a little sight glass. There's an oil reservoir in this arbor that will drip oil down on this bearing while you're using it, and it's been sitting a while. It has drained out of the oil, so I'm going to go ahead and get some oil put back in there. I'm just using a lightweight spindle oil, and I'll just kind of fill this up. And you kind of see the oil rising on that window to show you the level of oil. Taking a second to kind of drain down in there. And that's going to be plenty. We're not going to be using this really a long time, so I'll go ahead and button that back up. And I'm going to go ahead and kind of start it up now. A couple of things to note here. If you look on the bushings, you can kind of see a little run out in it. When you're looking for run out in these, try not to look at the bushings because those will kind of fool you. Those bushings are not, there's a little bit of play in each one of them, so the outside diameter of this is not necessarily running true to the cutter. You want to look at the outside edge of the cutter. And honestly, guys, there is a little bit of run out in this arbor, and that's pretty normal on a horizontal mill. Unless you got a brand spanking new arbor that's in just really excellent shape, they all have a little bit of run out in them. And one time I even bought a brand spanking new arbor for one of these things and put it in here, and it still had a little bit of run out in it. But what's important to understand is while this thing is cutting, even though there's run out in there, the bottom end down there is going to be consistently cutting the same depth going around in that circle. So when this cutter's cutting, you're going to hear it. It's going to be whomp, whomp, whomp. It's going to be cutting heavy in one area. And that's fine. You just need to kind of slow your feed rate down a little bit to compensate. Ideally every single tooth on that cutter is pulling equal load and cutting the same chip amount. When you got a little bit of run out in it, which is almost 100% of the time, a couple of teeth on there are going to be doing most of the work. It's fine. Don't get too upset about it. Is it ideal? Is it perfect? No, but it's reality, and that's just kind of where we're at. Now, I might be able to tighten my bushing. Actually, I see my bushing moving a little bit, so I'm going to see if I can tighten this up a little bit and maybe take some of that run out. But you're going to have a little bit of run out is my point. Let me make a few adjustments and see if I can improve it. Now, to adjust the bushing, there is a screw right here that you take out. This bronze bearing in here is on a taper, so as you tighten it up, it kind of squeezes it together. There's a slot in one side, so we can move this ring around and tighten it up. Let me go grab a spanner wrench that will hook on that. I'm going to put my spanner on here, and we should be able to tighten that up a little bit. You kind of have to adjust these. Every one of these arbors, this bushing is a little bit different. That's actually helped the run out, I believe. Now what you have to do over here is get that little round area lined up with so you can get your screw back in there. That keeps that from spinning while it's in operation. I'm just going to move it around until right there. My screw will go back in. That seems to be turning nice and free. And again, that screw just kind of matches that little notch there, and that keeps that nut from loosening up. All right, we got our bearing adjusted. And sometimes you have to loosen them, sometimes you have to tighten them again. These little bushings will vary in size by just a little bit, and that will make a difference. And again, I'm looking at the top of the cutter right here, just kind of up against something. And again, there's a little bit of run out in there, but that took a lot of it out. Don't pay so much attention to the run out on the tops of these bushings because that's not a clear indication. All right, we're going to put our work into the chuck on this. This one has a 3-jaw chuck in it. Not too far. There we go. I like for this to have a shoulder, that because my work is pushing towards the chuck, and when this goes up against the shoulder, you can't slip, it won't slip inside these jaws and move up in there and get loose. Again, that's a good way to ruin a gear. And then we will slide our footstock up on there, and I'll get some clamps and get this clamp down as well. But that'll support the work in the chuck, and then also on the end to give you some added support with the center. So the next thing I'm taking a couple of minutes to do is go ahead and set a stop so that this thing will automatically stop and not crash into my chuck. So on my feed lever, which is right here, you can move a little stop in and out and it will automatically kick out. So I've got fairly close quarters here before I crash, so I want to make sure I do that. So when you engage the feed, it's going to be coming along, it's feeding in, it's feeding in. This little lever down here is going to come over and boom, it's going to stop, and we've got a good ½ inch before we crash, and we've cleared the work here, so we've done all the cutting that we need to do. And then we can go the other way, come back out, index, go to our next tooth, make the next cut. So with that done, the next thing I want to do is get my cutter centered up onto the piece of work here, and we're just going to do an eyeball method that I've found that works real good for me. So let me show you that. So the first thing I'm going to do is move my work directly under the cutter, and I know the angle you're looking at looks like it's going to crash there, but it's not. You can see the run out in the video screen that we're going to be dealing with, but again, I'm not too worried about it. So I'm going to stop right there, and first thing I'm going to do is I'm going to stick my big fat head in here, and I'm just going to kind of roughly get it centered up by eye, left to right. And it's going to be somewhere right along in there. Now what I'm going to do is I'm going to raise my table up until I just barely get a chip on there. I just want to barely touch it. So I'm just going to raise it up real slow. I'm just moving it a couple of thousandths at a time here. All right. I just barely got a mark there. I'm actually going to raise it, drop it back down just a little bit. I'm going to move my table in just a little bit. I'm going to make another mark. I'm going to go a little bit slower here. All right, so it's hitting right there. You can kind of hear it. So now I'm going to move my table in and out slowly. I'm going to sweep across the top of that part. And what that's going to do is that's going to make a mark. And because of the way the curvature of that part, you're going to have the biggest part of that mark at the very top. So let me show you the mark now that I kind of got it made. So you should be able to see there's actually two marks there. There's one in the front and one in the back. The one in the back, the second one there is actually the one I'm working off of. But that is the top dead center of this piece. And now what I can do is I can just get my cutter centered up on that mark, and I'm going to do it by eye. This is going to be close enough. You know, this gear that we're doing is not a super precision, you know, going to be in the space shuttle type of gear, so I'm not too worried about, you know, it being just absolutely dead nuts perfect. It's going to be close enough within tolerance by just lining this up by eye, and it's just how I do most of my gears, and they work just fine. And this is how I was taught to do it as well. Next thing I need to do is get my indexing figured out here, and I've got my book that I can look up for the number of teeth, and for 22 teeth it says that I can either use an 88 hole or 66 hole plate. And I looked in here and I do have the plate that has 66 holes in it, which is the second line right here. And on the 66 hole plate I need to go 15 holes per index to get what I need. So what I'm going to do is I'm going to just bring my little scepter over here to 0 right there, which is where I'm going to put my pin to start. And I'm going to count over 15 holes and mark it. I'm going to move this scepter so that it will help me to index those. I won't have to count it each and every time. Bolt on here that will loosen up, and now I can move that other one around. And I'm sorry to blow this out with the light again, just make sure I'm in the right place. Okay, and again, let me double check. 15 holes. So that's 0. I don't know if you can see this. This one is circled in that line. That tells me that's 10 holes from the one over here. So I need to go 5 from there. 1, 2, 3, 4, 5. So that'll be 15 holes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to tighten this back up. And what I can do is I'm going to index this around. I need to move my part down to where it's in the right hole pattern. Right now it's on the second from the top. I need on the second from the bottom. So this dividing head has got 6 different plates that come with it, and each one of them has different hole patterns in it that you can change out depending on the job you're doing. Again, you can look up over here in the book and figure out which one you need and select the right plate for the job at hand. So I'm going to put that pin in the second hole, and I'll tighten this back up. I just got lucky this time, and the plate that was in there had one of the 2 options that I could do. So now I pull that out, and I go around over here to my hole, and I have indexed it the right distance. And I'm just going to make sure kind of that it lines up all the way around. Sometimes you got to fiddle with this to get it lined up just right. All right, and we're going to go back over here. So when we do the first cut, we'll go down, just move it down to here. Then I can slide my scepter around, and it'll automatically help index this from one to the other with this set. All right, I think set our depth of cut, and we'll be ready to roll. So I think the last thing to do before we start cutting is to set our depth of cut. Now, according to my calculations, the depth of cut for this gear, calculating in some backlash, is 366 thousandths of an inch. So we should need to feed down 366 thousandths from a 0. I'm going to call our touch off. We did 0. We're going to make a better measurement here in a minute to get it. I'm going to do this in 2 passes, basically. I'm going to do probably about 3/4 of the depth. I'll just go 250 thousandths. And then I will measure the diameter across some pins, and that will tell me exactly how much I need to go to get to the proper depth to hit the diameter that we want to get. So anyway, that's the game plan. I'm going to dial in 250 thousandths on the depth, and we're within 1 thou of the 0 mark. I'm just going to, for this, I'm just going to let it roll right there. So 250 will be 100 thousandths. That's 200 thousandths. And that's 50. And like I said, we'll make a measurement and calculate how much we need to do on the second pass to get it to the proper depth. This machine will easily cut it to the full depth. I like to do it in 2 passes just so that I can hit that number dead on and not just have to go strictly by the down feed. I can actually go off of a measurement to get it right. All right, we're ready to start making some cuts. So I think we're ready. We got our RPM set. We've got our depth of cut. We got it centered up. Right now I've got it set for a feed rate of 3 3/8 inch per minute. I typically set this kind of more by sound and feel and experience than anything else. We're going to feed it in there, and we may speed it up or slow it down. I'm not in a hurry. This is not a production job. I'm not trying to get this done super fast. I just want to get it done safely. So I'll put a little cutting oil on there, and we make our first cut. And that actually sounds really good. You can kind of hear where it's cutting heavy on that bottom, like we talked about before. That's fine. I'm not worried about it. I'll let it cut through. It is through cutting, and just make sure we stop where we want to. All right, let me back out, and I will index to my next tooth here. There we go. And we will cut in second tooth. Just let it go until I hear it get through cutting. All right. I'll go to my next tooth. And let's just rinse and repeat. We'll work our way all the way around. 22 cuts, and like I said, then we'll make a measurement and figure out where we need to go from there. Last tooth, and I can tell by because my next hole is lined up where I started, that we didn't miss any teeth or anything through there. So after this pass, I'm going to take some measurements. We'll figure up our final depth of cut, and we'll make another round, and those teeth will become much better formed and look more like gear teeth, and we should be to depth. So let me pull it out and get some measurements. So this is the way we're going to inspect these gears. I've got 2 gauge pins. These happen to be 0.2812, which is their fractional sizes. This is 9/32 of an inch. There's a range that you need to be in between. I usually try to keep the exact perfect size, which the exact perfect size would be, what is it? Where's it at? 0.280, but there is a range that will work, and this is in that range, and this happens to be some pins that I have in stock. So what I'm going to do is I'm going to put them down into the root of the gear teeth, and we're going to make a measurement across those pins. And I've actually already done it, but we'll just come in here with a micrometer. We'll get a measurement across the pins, and let's see if I get the same thing. I do. So basically I got 4.232 is what that measures, that distance. And using some formulas, the formulas are in Machinery's handbook. There's also some gear calculators that you can go to online and just put your information in. It'll calculate all this for you. But I know that my target with some backlash in that gear comes out to, what is it, 4.017. So that's what I'm shooting for. I'm measuring 4.232. So if I take 4.232, subtract 4.017, that means I got 215 thousandths total. Because I'm taking half of it off each side, I need to divide that in half, which comes out to 107 thousandths. That's how much deeper I need to cut. So I need to raise my table up 107 thousandths, make another round, and we should be right where we need to be. So we're going to do exactly that, and we'll inspect them again when we're through and check the measurements and make sure we're dead nuts on, but that should get us there. All right, we need to come up 107 thousandths. I'm just going to read off the dial here. I'm going to get my flashlight down here where I can see what I'm doing. So I'm going to go around to 50. So that's 100 thousandths, and I need to go 7 more, which should be right there. I'll lock my table down, and we should be to depth. So let's make another round and hopefully have a gear gun done here. All right, here we go. This will be to depth here. So I went ahead and got myself back around to my number 1 hole on here. And again, if we finish up in that hole, we know we did it right. This is going to get a much better looking profile to that tooth going a little bit deeper. We'll have the full involute form of that tooth. We'll pull that out. Go around. And tooth number 2. And the final tooth, and I can already tell I'm back over on where I started from. If I index the next tooth, it's showing in the same hole I started on, which again tells me we didn't miss any holes on the dividing head, which is always a good sign. So this gear should be all finished up when we get this pass done. I will measure it again over pins. Double check to make sure we got it not right, but I think we're done. All right, guys, there is our finished gear. This is the original busted up one, the multi-piece version. Everything meshes up good from one to the other. I did check that across pins again, and we're within about a thou or two of the depth. And when I calculate that number, I'm calculating in a little bit of backlash, a little bit of play in the gear. It's not a super tight fit. You do factor in some backlash. So we're well within the tolerance of where we need to be on the diameter across the pins. And that gear is finished up and is ready to put the governor back together. I went ahead and just reassembled this governor assembly. I did it off camera. If you're interested in how all this went together, you can go back and watch the video where I took it apart. And I basically did the opposite. It was just putting some things back together. So the gear on the end obviously was the broken part. Back here on the back side, these little pieces here are weights, and as the engine speeds up, the centrifugal force will cause these to go out. When they do, it pushes this piece down here in the middle, and that is what basically opens up a port that lets the steam into the engine. And this whole thing is basically self-adjusting to keep it running at a constant RPM. So when the engine slows down, it goes up. That's going to open the valve up so that it puts more steam in. Whenever it starts spinning out, it's going to slowly close that valve off a little bit, and when the engine gets under a load, it'll slow down, it'll open the port back up. It's just self-adjusting. It's actually a pretty ingenious design, and called a fly ball governor. And this one doesn't really have balls, but it has weights on it, which does the same thing. So anyway, that is what we were working on, and we're going to get that boxed up and sent back up to my customer, which is John Wall up in Cumming, Georgia. And for those that just want to know, this just came off of a Rumley steam traction engine, and like I said, up in Cumming, Georgia with John Walls. So hopefully we'll get this back up and going, or he'll get it back up and going, and everything will work like it needs to. John, I will note that I had to press this the little weight piece on here, and I wasn't exactly sure where it needed to be. I'm kind of guessing a little bit, and going back and look at the video, there looks like there was a little bit of play in there. You may have to make some adjustments to it to get it just right, but I think it's pretty darn close to where it was when I received it. So anyway, we will get that headed back up the road, and with that, that is going to be a wrap on this video. As always, thanks so much for watching. Please subscribe to the channel if you haven't already. Thumbs up, comments really help out a lot. Really appreciate you guys to do that. Also appreciate the guys out there that help support the site financially through Patreon, PayPal, as well as YouTube memberships. All those really go a little extra mile to help support things around here and help me to be able to take the time to shoot these videos and do all the extra work it goes to share my work with you guys out there in YouTube land. And with that, we're going to sign off. We're going to get out of here. We'll catch you on the next video. Again, as always, thanks for watching.